Good day, base chemistry students. So we are now on our first lesson for the quarantine season. We are done with differentiation or getting the derivative. So we will now be moving on to the next lesson, which is on integration or getting the integral of a function. Now you can think of integration as the reverse process of differentiation or getting the derivative. Think of it as like multiplication and division. Multiplication is basically the reverse process of division, as division is the reverse process of multiplication. So if you're going backwards from integration, you will get differentiation. If you go backwards with differentiation, you get integration. Okay, so we will be our first subtopic would be on getting the indefinite integral of some functions and the basic rules on getting these integrals. The first rule is called the general power rule. Now, before we go into the rule itself, let's have some terminologies for some symbols. So you can see this S figure. This is the symbol for integration. There's a history to this. It's really a letter S that has been extended. I think it was Leibniz who made this symbol to show that he wanted to get an integral. And when we are going to do integration, the function must always be appended by a dx. Once we go into your differential equations class next semester, this dx symbol will be made clearer why it is needed. So for now, let it suffice that there is a need for us to put a dx whenever we are going to do integration. Okay, so the general power rule states that if we are going to integrate x to a power n, then the result is x to the power n plus 1 all over n plus 1. So notice here that there is a condition. N cannot be equal to negative 1. Why? If this is equal to negative 1, then you would have x to the power negative 1 plus 1, which is 0, all over negative 1 plus 1, which is again 0. So what would happen here? You would be dividing by 0, which is basically a mortal sin in mathematics. No number can be divided by 0. And after that, we also put plus c. C here means a constant. It can be any number. It can be 1, 2, 3, 4, negative 5, negative 12, negative 1000. It can be fractions, decimals. It can be irrational numbers. It can be square roots as long as it's a constant. So again, what would happen here? You would do this. You would add 1 to the exponent and then divide that by that same exponent and then add c. So let's get into some examples. So let's say we are going to integrate x squared dx. So the exponent here is 2. So what we would be simply doing is add 1 to 2, the exponent, and then make a denominator 2 plus 1. So again, whatever is your exponent, that is also your denominator. And then add c. So of course 2 plus 1, that is 3. So our final answer is x cubed over 3 plus c. Let's have another example. Let's say we have x to the negative 4 dx. So again, we need to add 1, so that will be negative 4 plus 1 all over negative 4 plus 1, then plus c. And of course, negative 4 plus 1, that is negative 3. So our final answer is x to the negative 3 all over negative 3 plus c. So never forget about the plus c. Our next rule is called the addition or subtraction rule. If you remember with the derivatives, so we also had an addition subtraction rule for getting the derivatives. So this one is basically the same as that. So if you have two or more um, powers of x here, so you can actually just separate them into these two. So you can get the derivative of x to the n dx, and then plus or minus the derivative of x to the m dx. So again, our n and m here cannot be -1. So we can apply the power rule to this one here, and we will get this, and then apply the power rule to this one, and we also get this. So we get x to the power n plus 1 all over n plus 1, and then plus or minus x to the power m plus 1 all over m plus 1, and then this is plus c. Okay, let's have some examples. So let's say we have, we're going to integrate x squared plus x to the -2. So what do we get? So we will be integrating them separately. So we have x squared dx and then x to the -2 dx. So of course, x squared dx will become x to the power 2 plus 1 all over 2 plus 1. And then -2 plus 1 for the second part, x to the power -2 plus 1 all over -2 plus 1 plus c. Now notice that I only put a single plus c in here, because what we will be getting, this is plus a constant, and then this is so we get here one constant, and then here another constant, but constant plus another constant is just another constant. So let's say this was 5 and then this was 6, what you would be getting here is 11. So 11 is the constant, so we would just be adding a single c. And then we can simplify. So 2 plus 1, of course, is 3. And -2 plus 1 is -1. So this will be x to the power -1 all over -1. So we simplify that, 2 minus x to the power -1. And then this is still plus c. Sorry for the typo here. The plus c got omitted somehow, or the plus symbol. Let's have another example. So let's say we are going to integrate x to the -4 minus x to the power 1/2. So again, we will be adding 1 to -4, the exponent, and then make a denominator -4 plus 1. At the same time, we would be adding 1 to the power 1/2, and then have a denominator 1/2 plus 1. Then, of course, we still have plus c. So we simplify that. -4 plus 1 is -3, and 1/2 plus 1 is 3/2. Now, if you have a denominator which is a fraction, the denominator here becomes a numerator. So it's this one. That's why there is now a 2 on the numerator. Try to recall your algebra on how we treat, how we simplify complex fractions. So we have this final answer, -x cubed over 3. So again, the negative from the denominator, we move it to the front here, and then minus 2x to the power 3/2 all over 3 plus c. And then we have our third rule, the constant multiple rule. So if you have a function with a constant multiple, which is a, we can take out a and then do the integration with our function. So this function here, x, these are just basically polynomials that consist of x. So this is again similar to what we have in our derivatives. So let's have some examples. So let's say we have 3x squared dx. So what we can do is we can take out 3 and then do the integration of x squared. So of course, what we will have, that integral of x squared, that is x to the power 2 plus 1 all over 2 plus 1, and then we have a plus c. And then we simplify further, so we get x cubed over 3, and then we multiply that to 3 plus c. So the 3 and the 3 here will cancel each other out, and so we are left with x cubed plus c. Another example, we have the integral of negative 2 dx. Now, our constant here, it's the same as if we have negative 2 times x to the power 0. X to the power 0, or basically any number except for 0 that is raised to 0. So any number, if you have a to the power 0, this is equal to 1. So a to the power 0, as long as a is not equal to 0 itself, that is equal to 1. So that is just basically the same as negative 2 times 1, which is still negative 2. So with that, we can still use the power rule. So we have x to the power 0 plus 1. So our n here, our exponent is 0. So we add 1 to that. And then the denominator would be 0 plus 1. So of course, x to the power 1, that's still x. And then divide by 1, that is still x. So finally, we will get negative 2x plus c. Let's have a third example. So let's say we are going to get the integral of 6x squared plus 4x to the negative 3 dx. So just like the second rule, we can separate them into two integrals. And then we can bring out the constants. So we have 6 integral of x squared dx plus 4 integral of x to the negative 3 dx. So we will get the integral of x squared, again, that's x to the power 2 plus 1 all over 2 plus 1. And the integral of x to the negative 3 is x to the power negative 3 plus 1 all over negative 3 plus 1. So let's simplify that. Let's do the additions. So you will get 6 times x cubed, so that's from the 2 plus 1 all over 3, plus 4 to the 4 times x to the negative 2. Again, that's from the negative 3 plus 1 all over negative 2. So 6 and 3 here are both divisible by 3. So this will become 2. And then 4 and negative 2 here. This can we can both divide them by negative 2. So this will also be minus 2. So what we will have is 2x cubed minus 2x to the negative 2 plus c. Now, once you get comfortable with doing the integration, there's actually sort of no need for us to separate or to take out, separate for the addition subtraction. There's no need to do the separation, and also for the constant coefficients, there's no need to take them out once you become comfortable with how to do the process. So we will be showing that in more examples later on in this video. Um, as I mentioned also at the start of the video, integration is the reverse process of differentiation. So with that in mind, we can check if our answer is correct by getting the derivative of the answer. Once you get the derivative of the answer, if it matches the original function in the integrand, then you can say that your answer is correct. Recall Let's recall some of the examples. So the first example that we had was the integral of x squared dx. Our answer was x cubed over 3. So if we get the derivative of x cubed plus 3, I mean x cubed over 3 plus c, the derivative of that is x squared. So remember, to get the derivative, you bring down the coefficient, I mean the exponent, make it as a coefficient, and then subtract 1. So basically, you will be getting 3x squared over 3. And then the 3's here will cancel, so you are left with x squared. And of course, this is a constant. The derivative of a constant is 0, so no need to write the 0. Another example that we had, the last example that we had, the 6x squared plus 4x to the negative 3. Our answer there was this 2x cubed minus 2x squared, 2x to the negative 2 plus c. So if we get the derivative of that, we should be able to get back 6x squared plus 4x minus to the power negative 3. So again, 3 here multiplied to 2 will give us 6. So 3 multiplied to 2, that is 6. And then 3 minus 1, so that is 2 for the exponent. And then the same process here. So negative 2 times negative 2, we get positive 4. And then negative 2 minus 1, then we get negative 3 for the exponent. And again, c, the derivative of that is 0. Okay, so let's have more examples. So let's say we are going to get the integral of 3x squared plus 4x minus 5. So, as I mentioned earlier, there's really no need for us to separate them, separate all three terms, and also to bring out the constant coefficients. So we can just simply write them as one. So x squared, integral of that is x cubed over 3. X will become x squared over 2. And then remember here for the constant, it's like x to the 0, so that will just become x. And then we simplify. So the 3 cancel, so we are left with x cubed. 4 and 2 will cancel, so we are left with 2x squared, and then no change for minus 5x plus c. And then again, we can do checking. It's not required to do checking, but it would help. If we get the derivative of this, of the answer, then we get the original, the integrand from um, the given. Another example, if we have 5x squared minus 2x minus 3x to the power negative 2, so x squared again will have x cubed over 3, x here will have x squared over 2, x to the negative 2 will have x to the negative 1, again negative 2 plus 1, that should be negative 1 all over negative 1. So for 5 and 3, they do not have any common factors, so we simply write, we just put the 5 here at the numerator, and then 2 and 2 of course will cancel, so we are left with minus x squared. And then the negatives here will also cancel, so that will give us a positive. So we get plus 3x to the power negative 1 plus c. And again, if you do the checking, then this, the derivative of this, goes back to the original, to the given. Last example. So let's have 3x to the power 4 minus 2x cubed minus 3x to the power negative 2 plus x to the power 1 half. So what we have here would be, so again, x to the power 4, we will get x to the power 5 over 5. And then the integral of x cubed is x4 to the all over 4. The integral of x to the negative 2 will be x to the negative 1 minus 1. And the integral of x to the power 1 half is x to the power 3 halves all over 3 halves plus c. And so simplifying, 3 and 5 do not have a common term, so we just put the 3 to the numerator. 2 and 4, so divide this both by 2, so you will have 2 in the denominator. And then the minus and the negative will give us a positive 3x to the negative 1. And again, because the denominator is a fraction, so we bring 2 up into the numerator. So we have this. So 2x to the power 3 halves all over 3 plus c. And again, doing checking. So getting the derivative of the answer will bring us back to the original given. Okay, so that would be our first lesson for integration. Watch out for the next upcoming lessons. Have a good day.